As the world shifts towards sustainable transportation, electric mobility is poised to revolutionize the automotive industry, paving the way for a cleaner and greener future. Our next panel discussion has experts from this domain who will delve into this theme and share their insights with us. I invite onto the stage our panelists, Mr. Shreyas Krishna Sitapati, Chief of Staff to CTO Aether Energy, Ms. Anita Dhyaneshwar, Director of Flowtech Technologies, Professor Kaushal Jha, CEO, Center of Telecommunications and Energy, IIT Madras, and S.A. Sundareshan, Vice President of Ashok Leyland's EV and e-mobility business, who will be moderating the session. Kindly come forward.
Good afternoon, everyone. It's going to be tough following on that very energetic session on energy storage. Let's, at least we'll be mobile and we'll start moving. So just to get started, so sustainable mobility more or less at this point means electric mobility. So before we start, I just want to have a round of introductions. So let's start with Anita. Can you introduce yourself and your association with electric mobility? Any personal stories will help.
Hello everybody, good afternoon to one and all. I'm Anita Dhyaneshwar, co-founder and director of Flowtech Technologies. Flowtech is a 3-year-old startup incubated by IIT Madras Incubation Cell and nurtured by Center for Battery Engineering and Electric Vehicle. So we focus in the design and development of EV chargers. When it comes to chargers, we work on public chargers, portable chargers for 2-wheeler, 3-wheeler application and DC to DC converters. We also have a tie-up with Salcomp as a manufacturing partner, where Salcomp is the world's largest mobile phone manufacturer today, and we are the design house for the electric vehicle chargers. So my journey with electric mobility started in 2015, where we were given a task of identifying the international standards available worldwide and adopting them or redefining them for India, under the guidance of our professor, Dr. Ashok Jhunjhunwala. And today I continue to be the part of the BIS panel, and my strength is more on communication protocols. So thanks for this opportunity and looking forward for the discussion.
Thanks. Okay, we'll move to Kaushal. Same question.
So there is a center for battery engineering and electric vehicle. It's a center of excellence of IIT Madras. And then we have another center of excellence in energy and telecom. Telecom is more about IoT. So I head both the centers here in IIT Madras as well as in IITM Research Park. And we work around every subsystem on e-mobility. Either it is a battery, means energy storage, or it is a prime mover, you can say motors and controllers, or it is a chargers, which I think we work with Anita and several other people, or it is management and analytics of, because there is a huge amount of data in the electric vehicle, that, or recycling of all those things, either it is a battery or motors or controllers. So this is all the things what we do in this center. In the past we have been working with multiple OEMs as well as on the ecosystem side. My first experience with e-mobility starts with something like a vehicle known as e-Verito in around 2012. Just passed out from IIT Madras and working with Mahindra & Mahindra, and then Professor Ashok Jhunjhunwala, where he was the first owner of e-Verito, and all about energy management, why air conditioning takes that much of energy other than the driving. So the thermal is another expertise what I have. So, and then we move further. Now we know that energy management plays an important role. Either it is a charger or it is a battery or motors and controller. We look for higher efficiencies, even though there are a lot of products available in the market. But what is missing in almost all of these things is efficiency and optimization of that. And that we also take a great work towards on that side, so that it becomes energy efficient. It gives you more mileage, more kilometers than with the given size of batteries or motor controller.
Thanks. Shreyas.
Good afternoon. I'm Shreyas. I'm from Aether Energy. Aether is a now 10-year-old startup that was incubated at IIT Madras and has now subsequently grown to almost 2,500 odd people with a very strong R&D that's focused on the design and development of electric two-wheel scooters and charging infrastructure. My personal journey with EVs started with Aether. Prior to that, I worked in turbines, steam and gas turbines for 7 years. Then, with all those moving parts and all of those gases being burnt, I started working on batteries which had no moving parts and basically just sat there. But then I started as a battery engineer, worked my way up and headed battery and powertrain at Aether for a while, and then vehicle integration as well for some time. Now I work in the CTO's office as the CTO's chief of staff, driving various technology initiatives in the company.
So people have said that EVs are really not new. They predate internal combustion engines actually. So more than 100 years old or 120 years old technology. But have we really progressed in this front as we should have? So I'm going to ask the panelists for a report card. So first for Kaushal. So from the perspective of the universe or Earth, not just mobility or not just one small this thing, holistically, where do we stand? What's your report?
So a lot of talks in the morning about how we are going to be quite in a mess. We are already there today, like flood, extreme weathers and all those things. And it was one of the reasons that we had to postpone from last 4th and 5th to this 4th and 5th. I have been around Research Park during that time because we had so many guests. And this similar situation is almost everywhere. So if you look upon US or Europe or Africa, everywhere this situation is there. So what we understand overall, if you look upon Earth, it's all about GHG, greenhouse gases. And it could be CO2, it could be something else also. But that's on combined term we say, because of that's all happening. Now, the question is that can we reduce it? And then there was some talk about that, okay, modular nuclear reactors and why it was not gaining traction in the past, because everybody was willing to not go for slightly unsafe what people think during that time, then better safe than the coal, gases or oils. But this all produces GHG. And if we have to remove this GHG from the environment, then it's become like carbon captures and all those things we talk, which is quite costly. So if we have to really work around on this GHG, so there is no other way that we have to work around the renewables, because we cannot compromise on our comfort, the technology, or what we say progress, or what we say GDP and all those things. That has to keep on improving. And in that we require energy. The same is with the mobility also. Mobility is one of the aspects. If GDP grows, mobility is equally responsible. It has almost 8 to 20% contribution in the GDP. So GDP goes up, mobility is expenses as well as this GHG also goes up in proportion. So if we have to remove that GHG, so we have to go to renewable. If we have to go to renewable, then we have to also move our mobility sector from the fossil fuel, which is responsible for the GHG, towards renewable. Now I cannot put solar panel in the vehicle and expect that's 100 kilometer per hour speed, because we are now looking for 100 kilometers even in the city. When I drive from here to Chengalpet up to Tamram, yes, 20, 25, 30, but after Tamram I generally go 80, 100. That would not be possible with just putting whatever efficient solar panel I provide. Today it is 22, 23%. Tomorrow it can go to 26%, 27%. There is a theoretical limit itself is 30, 31%. Beyond that you cannot. And the surface area which is available in a vehicle is hardly 4 square meter to 5 square meter. In such cases, the energy or power available is quite low, so we have to compare with the petrol, diesel, or fossil fuel, and that's where something comes like energy storage, and that's where we also talk about lithium-ion battery a lot because of its energy density and power density, not because that other things cannot be used. Lead acid. We have tried in the past. There was a vehicle known as E2O by Mahindra. That was basically with the lead acid battery. And when we are talking about 100 years back, in fact, we had a EV that was the lead acid battery. People used to change whole bank of the lead acid battery into the vehicle. So, and then we moved to the fossil fuels because it was much more energy efficient at that time. Now again we are repeating the history, but with the better technology, better energy density, better power density, and that's how the whole world is moving towards. And the mobility is an essential part of that side towards decarbonization, removing GHG or reducing the GHG contribution on that. So that'll.
Yeah, thanks. Now we'll go to Shreyas. So as working in a startup that kind of pioneered, at least to the masses, electric mobility. So how do you think India has performed and OEMs in general have performed? Have we kind of capitalized on all the opportunities? Did we miss some?
Yeah, so I can look at this in two ways. I can look at this as glass half empty or half full. So I'll go with the half empty first, get the bad stuff out of the way. I think we're a little late to catch the bus. I don't think we saw the trend as early as we could have in terms of giving the incentives that needed to be given. That said, we're catching up fast. Right? I think there is also a lot of tentativeness still, in policy circles, even amongst the public, I would say, that they're not entirely convinced by electric, right? It's becoming more commonplace, more consumers are adopting it, but it's not entirely fully embraced. That there is also not, it's never a climate discussion. If you think about EVs, it's always a kitni deti hai sort of conversation. How much is it costing me, right? So I think if I look at it glass half full, I don't think it's linked to our shared future yet. That this is urgent, this is important. Yes, there is the economics of it, but there is a bigger picture here. I don't think that has really settled. So that's the half empty look. Right? But if you look at the good side of it, EV adoption is higher than ever. It's been a great year, 2023 in particular. We've built capabilities to build vehicles across different vehicle types. Right? I actually took a bus from Bangalore to Coimbatore recently, an electric bus. So that was something new. I ride a two-wheeler to work, obviously. And I think you can see Nexons everywhere. Right? So as a country, we're capable of building these products. We are slowly stepping deeper into the value chain. So you'll see cell manufacturing happen soon. Almost every subsystem in an EV is today produced in India, barring semiconductors and cells. And we're leveraging our leadership position in two-wheelers to also make world-class, world-leading products, in EVs. So the top, I think, 3 or 4 two-wheeler companies by market cap are Indian. And those companies have all taken electrification seriously. And if you look at electric two-wheeler products from India, I'm not saying this because I'm from Ather. If you look at electric two-wheeler products in India, they are actually superior to their Chinese counterparts. So we're not starting from a very low base. We're not making sasta scooters, right? We're making good scooters, good motorbikes. So that's the glass, half full picture. So I'd say if you want me to score it, it's 5 on 10.
Thanks. So Anita, what about the other key important factor, the infrastructure, right from power generation all the way to taking it to the vehicle?
So when we talk about charging infrastructure, the charge point operators play a key role in bridging the gap between the users to the whatever the chargers. When we talk, the infrastructure not only covers charger, but it's a complete ecosystem where it has a central management system and a mobile app which helps the user to locate, identify, compatibility check, reserve and access the chargers. and it also has to have an integrated payment mechanism with the metering facility built in. So with all this in place, there are a lot of charge point operators are there today where they are trying to deploy the chargers by identifying potential places, and the deployments are happening. So at the end, for each charge point operator, we have a central management system and an app associated with that. So this gives the burden for the users to have 10 different apps to access the different charges. So similar to the unified payment interface, something on the infrastructure, unified infrastructure, something has to happen. So there's already a standard existing, which is IEC 63110, which talks about the protocol for management of EV infrastructure, charging and discharging, both put together. They cover the management of session, monitoring, payment, authorization, and also enabling the interoperability across the charge point operators. So all the charge point operators should look forward in deploying that and getting it in place to give the user a hassle-free experience.
Thanks. One follow-on question to everybody in the panel. So, EV is in a very, very nascent stage. And if we see abroad, there's a lot of cooperation among all the players in the ecosystem. Like consortiums get formed and they work in developing standards. They work in, of course, Tesla was a outlier. But otherwise, in Europe, especially now, it's happening where for hydrogen, Daimler and Volvo got together to develop fuel cells. So, is something like that should have, if it happens in India, would that make things better, faster? Are we competing among ourselves and not really competing against the overall global warming or climate change?
Right. Yeah. So, yeah, there's in general a dearth of standardization. Even our own qualification standards they're derived from international standards. So, I think I read this somewhere. I'm unable to cite the source, but the highly industrialized economies also always have a very strong standard regime governing it, whether it's Japan, Germany, the US, Europe, and so on. So I think that's something that we need to focus on. We haven't done that as a country, and we need to start doing it. In terms of EVs in particular, yes, we haven't come together well enough, right? We can't agree on a simple charging connector standard, let alone swapping standards and so on. So a long way to go there. That said, I also think it's too early to standardize components in particular, because everyone is trying to make this business work, right, in terms of the economics. So if you are trying to tell people, no, you shall only make a standard battery, for instance, right? No one's going to sign up for that. Where's the competitive advantage going to come from? So I think it's a little too early for that in terms of component standardization. But I think as standardization as a country, yeah, we've got to do.
So some small point if I would like to add here is something, if you look upon some consortium type of thing, so yes, that is happening a lot in academic, and in fact we do have in IIT Madras, if you look upon, so there is something known as Energy Consortium, and in fact our center becomes a part of that one. It's also work independently, and also whatever the goal of that center it is there. If you look upon outside academics, so I don't see too many things move on R&D side. People do have the technology collaboration, like Mahindra is working with Volkswagen for EV architecture. Tata has been working with Land Rover, even being one company, but still these are two different companies. You are working with Switch Mobility has bought technology plus developing all those things. But I don't see that is a very significant, because a country like India, where we have almost 1.5 billion people and then our earnings are really low, it would be a good thing that such big companies come together and then say, okay, let's develop this technology and you can do the the specific enhancement for your particular thing. So it becomes easy money flow, and then that can be adopted to the lot of people, which that is not happening a lot. As per standards and other things are standards and regulations are concerned, yes, there are a lot of standards and regulation has already been done in US and Europe. A lot of them is going to be get adopted with the country specific changes. So like if you look upon AS 156, so in amendment 3 or AS 038 amendment 3, this all has come because of the two reasons. One is globally people are trying to go on that side, and also we started getting a lot of issues like some thermal runaways here and there. It might not be because of the cell, might be because of something else, but that started catching attention, and then people were forced to do that one. So instead of getting the force to do that one, if we can take a proactive action itself, keeping people at the end of the day, people at our center of imagination or the work, then the things would be further better, which we are not doing right now. We are looking more on that. Okay, can we do something this, and can we make a profit out of this one? So that has to be slightly changed. Nothing wrong in that approach, but slightly changed. People have to be at the center of all the things.
Thanks. Okay. And electric mobility has come a long way. I mean, just if you see in the last 20 years, 25 years, GM had been experimenting with electric cars even before Tesla, but nothing really took off. Ford also introduced a few. At some point, the entire industry thought pretty much hybrids are the only way. Pure electric vehicles can never meet customer requirements until Tesla came and changed the entire game. But looking at the progress over the last few years, which do you think was the biggest problem that got solved, or which kind of excited you to be in this industry, saying this is a real breakthrough? So each, again, we'll start with, yeah.
So when we talk about the advantages, I would say that whatever the standardizations effort taken in terms of considering the climatic conditions of India is something which has put up the public infrastructure stabilization in place. But still there's a long way to go, because people are forced to adopt these standards, and the awareness of using these standards in the products is still, there's a gap to be filled in. And also the AC standards, when you talk about the different wattages which are there in place, still the compatible vehicles are yet to come. So going forward, the standardization in place and mandating will help us to take a lead towards the mobility.
Okay. Shreyas?
Right, you're the one big moment. I think it's like you referred to it, right? It's undoubtedly what Tesla did. And I think for me, probably the moment is when their factory went live, the Gigafactory went live, that people understood the connection between a fundamental shift it's a once in a generation shift in technology and how that looked. Right? I don't think anybody knew how it looked, and nobody had a roadmap. I think what that company has managed to do is to say, hey, this is the way, this is the blueprint, and then I think others have adopted it in different forms. So I think that's quite obviously the definitive moment. Even for me, I was considering a master's versus joining Ather at that time. And if Tesla wasn't there, I wouldn't have thought electric vehicles are as cool. Right? So it was definitely a factor even for me to jump into the industry.
So personally for me, it's all about new learnings. And I love to, no, it's not new learning in the case of equations. I'm able to apply the same equation to the new field. Equation does not change much. It's also about interdisciplinary work, with the learning of some particular things, how I can apply to others. And that's really helped me a lot to work in different fields. So previously I was a thermal guy. Now I am basically an electrical person. Tomorrow I don't know, maybe something else. But basics remain same. The question what you have asked previously about that GM and other things. So that's a Europe and US. They have been doing a lot of things from long time, and we have been also doing. So we do had a company Riva, correct? That's older than Tesla. The only thing that why we didn't catch up, because might be people were not ready to take it up here, or industry were not ready to set up it further. So I can say in that ecosystem was not so good. And a couple of days back, one person was asking me which vehicle should I buy. So I said 3 years back, if you would have asked me, I would have suggested you some ICE engine vehicle. But today, if you really wanted to buy, go to EV, because even you wanted to come from Chennai to Bangalore, at least there are 10 charging stations in between that. You can easily utilize that one. So yes, over the time, infrastructure will also get developed further, and on and over everything, what we want is cleaner and cleaner world. So that's makes me motivated to keep on working on these areas.
Having covered a long way, we still are a long way off, because only in two-wheelers we see respectable numbers for electric vehicles. Everywhere else, passenger vehicles, of course, there are a few models and there are reasonably good. Buses outside of government, very few. Intercity buses, there are very few, but yeah, that's a start. But again, it's a drop in the ocean. And when it comes to trucks, we're nowhere there. So what is holding us back? So what technical challenge, if it is solved, okay, not necessarily technical, what challenge, if it's solved, it'll actually advance us significantly further in this electrification journey?
So in our journey, if I want to say specifically, when we work with this designing portable chargers for OEMs, each OEM have a different set of protocol, different set of connectors. And for the same product, we are forced to implement at least 10 different protocols to give out as a sample. This is one part, and we don't get the access or privilege to the battery, which has that counterpart. So for all the protocol, we also do a BMS simulator to get it done, test it at place, and then provide the sample. So this is something has to be addressed. Then the second part would be on the nominal voltages. So nominal voltages, earlier 48 volts seems to be nominal, and recently 51.1 is becoming nominal. That is fine. But when we do a design, if you want to cover the wide voltage range, we also have to accommodate that design into our, we have to consider that into our design. And this has an implication on the costing part of it. And component sourcing is the biggest challenge which we face today. And I'm sorry, most of the OEMs, they just get it imported, and that is how the market is flooded with too many startups disguised through this in the name of startups, where the chargers are imported. So this is something maybe somebody has to take into consideration and do something for this.
Right. So I presume you meant as a country or as
Again,
as
global.
companies.
Yeah,
Okay.
global citizens.
So I mean, as a country, it's getting deeper into the value chain, right? So typically, if you look at the battery value chain, there are parallels drawn with the oil and gas value chain, where there's an upstream, a midstream, and an upstream, and so on, right? And there's the mining, then there's the midstream, and then there's the final part of the value chain where the pack is put together. Now we don't have resources to do mining, or we're discovering a few, but it's mining. Developing a mine takes a good part of a decade, right? So that's going to take a while, even if those reserves are proven. We've developed the latter end of the value chain, where we build all these components. We can build battery packs. We're also starting to build some cells. I think to crack the puzzle completely, you need to crack the midstream, which is taking minerals and converting them into cathodes and anodes, which is a weird set of skill sets we actually have as a country, but we haven't deployed towards this. Right? It's process engineering, it's chemical engineering at scale. it's not like we don't do it. We have a thriving pharma industry, which is also sort of process engineering, right? But it's different. This is sort of the marriage of metallurgy and process engineering. So we need to crack the midstream in batteries for the skepticism to go away, because the value chain in EVs is so heavily dominated by our not so friendly neighbor. So I think that's the big hurdle as a country, also for electric mobility to gain the complete confidence of all stakeholders. Right? As a company, I think all companies in EVs is achieving the scale to get to profitability. That's the big thing for us. I think the day the first EV OEM goes, purely EV OEM goes profitable, will be a watershed moment. It's not too far away, though. What happens?
So I don't think technology has much to do with, because we do have technology either in India or outside, and we know we can also build upon on that one. But I see two things. That any system has to be process driven, not the people driven. And most of the things what we see in India is basically people driven. And so you have to convince a lot of people for doing anything. If it is a process, then it becomes quite easy to make anything. The second thing, yes, a bit on infra, which is anyway improving day by day. And the third one, what I could see is the cost at the end of the day. Unless we don't start building for the mass, that means cost has to come down drastically. It will not get adapted so easily. And maybe that cost has to be initially absorbed by those organizations, because even being a person, what I am here, I have invested my first 30 years in learning, then only I was able to deliver. So for every organization, it has to be done, and I don't know from where they'll get support. That I'm not sure about on the money part. But then only we can move towards the volume. Otherwise, we'll keep on doing in bits and pieces and may not be able to achieve. So the volume is important part. Infrastructure second important, and technology. We know we are 1.5 billion people country. We can do that one. That we are sure about.
Yeah. Now, before we go to the audience for questions, I'm going to ask the usual questions that I get in most events like this. So the first question is from diehard internal combustion engine fans, or they are fanatics. So just a BS6 vehicle is cleaner and friendlier if you consider well-to-wheel emissions, or mine to whatever in case of EV. So given that, why electric mobility? So again, this question unfortunately was meant for the missing panelist, but anyway, I'll ask Shreyas as the other OEM.
Yeah, so it depends is the answer. It depends on where the energy source is from. So people tend to assume that EVs will save the planet or cut emissions on their own. They can't. They also need energy from somewhere. Law of conservation of energy. EVs don't produce their own energy, right? So it depends on the mix of renewables in the grid. And depending on that assumption, the wheel-to-well emission changes. Now, if you take it, for 2023 or 24, yes, it's not going to look the same. And also, if you look at the life cycle of the entire vehicle, most EVs, like say a Tata Tiago, for instance, would actually be better than an internal combustion Tata Tiago. But if you take a really large vehicle with a 90, 100 kilowatt hour battery pack, then it's not a fair. So it really depends. That said, if you look at 2030 or 2035, when say a large part of the grid is renewable, then there is no comparison. It's not even a debate. So it's a moot point for me. I feel like we're chasing our own tail if we're having this debate over and over again.
I would like to add here one line, very simple line, especially people who are from the engineering background. There is a very first subject we read, engineering mechanics. That is there in the 10th and plus 2 also. There is something known as frame of reference or reference point. What we do basically for IC engine, we take reference point from when the vehicle is made, and then we are putting petrol and diesel, and then we talk about emission. That's what is BS6, BS4, BS7, what we are talking about. And when we talk about EV, we start looking for, okay, lithium mining, cobalt mining, cell making, and so. No, you cannot compare like this way. If you really wanted to compare that emission, then if you are comparing in IC engine from crude oil to emission, please compare in that way. Then you can compare from. Otherwise, you compare, if you are comparing vehicle to vehicle, compare electric vehicle and the IC engine vehicle. And everywhere you'll find that electric vehicles are much cleaner, much environmental friendly than the IC engine vehicle. If anybody has any questions in that case, I can offline sit with them and can do all the calculation. I have done several times this one. So frame of reference is very important.
The next question that's asked is, India as it is has so many power blackouts. So wherever you going to get the electricity if everybody moves to electric vehicles? This is for Anita.
Yes, sir. It's true that we don't have electricity. Even Chennai last month we had this, and there was a power outage in the overall country. So to answer this, there are so many technologies which are happening today in terms of renewable energy infrastructure, RESS, and all those things. But when it comes to charger per se, I would say that the dynamic load management algorithm should be built in all the chargers to support the grids. And also we should have something called a time of day metering, so which will encourage the users to use the grid accordingly. And more than that, giving back to grid is something which we all have to work together, V2G or V2H, through some bidirectional charging.
Thanks. The next is one of the reasons why electric mobility is preferred in India is the fact that it can save us foreign exchange that we are spending in importing all the crude oil and other things. But then for EVs, the question is, are we going to end up replacing that crude oil with other minerals? Lithium is what everybody talks about, but then there are so many other things that go into an EV, quite a few critical resources. So what is the answer to that?
So no, it's not like that way. If you earlier session also it has been told that lithium is everywhere in India also, but it's not only about lithium, correct? We have nickel, we have graphite, we have cobalt, and in fact the cobalt and nickel is major problem if we look for the India, and that's because that we have to import. Going beyond that one, what we have to look upon is that we have been using the cell phone from last, I think 1998 we have started using, and now it is 2023, so almost 25 years, and almost all those batteries are lithium-ion batteries. Different compositions, different chemistries, but it has the similar things like lithium, cobalt, manganese, nickel, all those things there we have. Laptops, which we have been using from last 30-35 years, has the similar batteries in that also. And new generation EVs, right now we are importing a lot of those batteries from outside. So these all are we have. So that means I can say all those minerals are already there in much refined form, but we have to separate it out. And that's where the recycling, or we say it's urban mining, becomes very important. And if we keep on recycling these things, and that becomes indigenous technology, indigenous people, indigenous capital, and much cheaper than taking out those elements from the ore. So in that way, yes, it won't be like we keep on buying all those minerals or elements from outside and putting back our all precious resource like foreign exchange to there. No, it won't be like, but petrol and diesel, we didn't had any option. We had very hardly 5 to 10% of the reserve, which anyway we were utilizing. Rest of the things we have to buy. But in this case, we can make it as an opportunity. In fact, we can make it opportunity to the world, because everywhere else these technologies are not available, or if it is available, also it's a very nascent stage. We can take those things and can utilize as a recycling things in India. So no, I don't agree completely on that one. Maybe for a couple of more years we have to do that one, but over the time we would be self-sufficient in all those minerals.
So now that we have preempted these questions, now the floor is open. Yeah.
Thank you very much. I'm not an EV guy, but an energy man. My name is Ashish Vaishnav. I come from Pune. Having been, also grey-haired now, 50 plus, lived in a generation in India which was trying to from have-nots to getting money, affordability. Electricity is something which possibly you've seen has not changed as much as what we thought other things have changed in our lifetime. I live in Pune. I have not blackouts, but every day there is my inverter in my house. I think inverter in my house actually sets the trend in terms of what is your power infrastructure. And here we are adding EVs, which I don't think so any general man knows what it entails. He's worried about charging his mobile. He's worried about charging his laptop, like you said. It doesn't work. But now an EV is going to be an animal which he doesn't know in terms of the charging part. We talked of the charging infrastructure standards and all, but that's to do with the, like the C plug and the, USB type. But the basic thing, and what we heard in the morning is, if India has to move from 7,000 gigawatt hours to 28,000 gigawatt hours, is it business as usual we are talking the GDP growth, or now with this tectonic changes which we are bringing about, the way we used to travel is going to change to EV, which is going to put the load on the power. And with the growth, we are talking of 3-4 million vehicles. And I have had a chance to live in China for 8 years, between 2004 to 12. And I used to tell people then that I'm living in future of India if it could be. And I think you know what I'm saying. So China has 30 million vehicles. So if that's the way China's infrastructure has grown, similar India will grow. I don't think so we have to look at any other nation. So my basic question was our power infrastructure, which is going to do this, and we have a session on heating, cooling. You'll realize what cooling is going to do to India when everyone's home starts getting air conditioner before an EV vehicle. So how do you think our SEBs are possibly one of the weakest links? And unless infrastructure at that level grows, how do you put a charger in a society or a house or something which will take care of this high voltages and all? So how does that get handled is my question. Otherwise, we'll be saddled with equipment where we will use DG sets to charge. That kind of situation. That's going to be phenomenal. It's happening. If you look at every May, June, it happens. So we have a green nameplate. I'm not talking about the green part of it, but a basic nature that I will not be able to charge only because my infrastructure design, afford it to. So that's a question. Sorry, a long form, but I'm trying to give a context
I'll
of it.
answer
Thank
you
you.
only in 1 or 2 lines. Maybe other panelists can add upon. When we are talking about grid, today India grid infrastructure can take 2 to 3 times load what we have a real load today in the grid. I'm talking about the grid. Now the local distribution point may be a weakest link, but that comes from the local governance structure, like maybe corporation, that municipality, or the local state government. But if you look upon overall grid, we don't have any issues in the grid audit. It happened, I think, around 20 years back. We had one blackout, and now last month we didn't have a power, not because the grid was failed. It's because people should be safe, because the electricity which is flowing all around is in waterlogged area, so electricity current should not pass on that one. So I don't see the grid is an issue, sir. If tomorrow it is required, they keep on improving. So grid infrastructure is quite good in India even today. Local distribution system is different. That we have to fight with our local government, local system on that one. And moreover that, it's not, I don't see even the local infrastructure is so bad. It's because a lot of illegal activities happens on that side. So that's finally I cannot blame it to somebody else. It's which means we need to improve. Especially when you look upon the electric vehicle or even your home utensils, everything is becoming smart and smart. Now, I have a house in Bihar where we have the meter where even a single unit it will automatically cut my connection from that one. And I don't know, it's a new meter, even I don't run anything, still the meters move because it's a very sensitive in the sense, even a small losses here and there, it's kept capturing. So government is also trying, or local discom utility is also trying to move on more smart meters, more smart things. So we are improving, may take some more time. So I don't see that as much issue there. Regarding vehicle, if you look upon electric vehicles, a good thing about electric vehicle is that it can also be considered as one of the storage. When you have some time where the power demand industry is more and they are unable to provide to the home, in that case, you could use your car itself as a inverter system. And that's one of the technology people are working around the world. And in fact, we are also working here, and we say it's a V2G, vehicle to grid. So it's not only grid to vehicle, it's a vehicle to grid also. And that's a decentralized system. So that help a lot even in the local level. A single apartment level, people can adopt this type of thing. So hopefully things would be better. That's what I can say on that.
Thanks. I think we'll move on to the other question.
Yes, Namaskaram. My name is Ganesh. I am not an engineer or a technical person by any stretch. Okay, but my general question to the panelists, especially to the person from OEM, is that, when we talk of two-wheeler EV in India, right now we are talking mainly about low voltage drivetrains. Okay, so do you see a trend where this can move to high voltage drivetrain in the future? Is it already happening? And do you think because of a lack of it moving towards high voltage drivetrain, the adoptability of two-wheeler EV is lower in India?
Shreyas?
Yeah, thanks.
So it depends on the sector that you're talking about, right? So when you talk about two wheels, the requirements of the market, the mass market, is satisfied by a 48 volt powertrain because power levels do not get to a point where, because of the low voltage, the current levels are so high in the system that thermals become a problem, right? Which is why you see most products being 48, 51 volts, as she said, because it's manageable, right? But once you start getting into higher performance territory, I'm talking north of 10 kilowatts, right? 8 to 10, it's a debate. Then it starts making more sense because then you're pumping so much current through the system that the efficiencies start dropping and it doesn't make sense anymore. And there's more tangible hit on range as well. So I think for that segment and also for maybe even the three-wheeler segment, which is also largely 48 volts today, it does make a lot of sense. Four-wheelers are obviously all high voltage anyway. So I think not for the mass market vehicles because that the level of performance they desire and the gradability in terms of say an 18-degree slope, right? All of that is satisfied by a 48 volt powertrain, which is why you don't see that movement yet. Just to add, the other thing is that there is not enough of a range difference between, say, a 48 volt or 60 volt powertrain for two-wheelers because battery sizes are generally quite small, right? Now, when battery sizes get big, then the difference between voltage platforms also get more marked. That's also one reason why you don't see this big move to 60 or 72 volts.
So I'll just add a small point here. See, we have a very simple categorization of low voltage and high voltage. anything below 60 volt DC is considered as low voltage. Anything above 60 volt DC is considered as high voltage. Now, at the end of the day, it becomes current because voltage and current together is like a power. So can we handle that much of current? And in the two-wheeler segment, most of the things can be covered till 60 volt system itself. So why do we go higher voltage? Because it's unsafe for human. We have to do much better engineering in that. And that's why you see almost all the two-wheelers or e-rickshaws are in 48 volt, and some small Tata Ace type of vehicle also, or three-wheeler especially, are also in 48 volt. It's nothing to do with anything else, the range and other things. It's all about safety aspect. Anything beyond that, people go for higher voltage. So both the technologies are available, well matured, and people are working on that one.
I think we are running towards the end of the session. Yeah.
Yeah, so there was a topic which came up in the discussion regarding how startups are doing white labeling to run their business in both charging infra side and the EV side. So do all the panelists think that the stricter policy framework is required to, control this? And if yes, how would it affect we are pushing towards faster adoption of both infrastructure and the electric vehicles. So how would it affect that?
Right. So I think it's gotten quite strict already. Last year was that year when the government clamped down on a lot of companies that were white labeling, and then you saw the market share numbers completely flip because of that. So I think enough is being done. There's also like a thin line between how far you want to go in terms of localization, right? You want to check at an assembly level, at a component level, at a material level. You can go all the way to the mine if you want to. So I think there is still a little bit of confusion on the policy level, on how deep we want to localize, and I think a little bit more clarity there would help. But I think the government's doing enough to drive home the point that if the product is not developed here and it's basically just labeled and sold, then they're not going to be eligible for any kind of incentive from the government. So I think that's fairly clear.
Yeah, one question.
Last question.
So, hi, I am Devang Gandhi, and I want to ask that more than the fear from IC engine vehicles, there is a lot of fear from the hydrogen upcoming green and blue hydrogen. So, how does hydrogen economy, try to destroy the EV market? Because once hydrogen will be coming, the EV segment might be, getting hampered a lot, maybe. So that is the question.
So if I understood correctly, you wanted that's why hydrogen is not coming in EV, correct?
Sorry?
Okay. So very simple math I'm saying you. So let's suppose 1 unit of electricity generates 1 kg of hydrogen, and then 1 kg of hydrogen generates how much? Let's suppose half unit of electricity back to the vehicle, because 50% is what maximum efficiency of this one. So what you got from 1 unit of electricity to 0.25 unit of the energy to the vehicle, correct? The simple math it says. However, if you use energy storage, like hydrogen is nothing but energy storage there, correct? If you use lithium ion batteries or even sodium ion, even lead acid, the energy conversion factor is almost 60% to 94-95%. And that would always be better than 25%, correct? So hydrogen is not going to kill e-mobility ever. Hydrogen is much more required in other industries like cement, steel. They don't have any other option. E-mobility at least has some option. Long distance trucking and other things, I'm not sure about how it will move. But my personal gut says it would not be even viable in that also. So that's my personal opinion.
Thanks everyone. There's a lot more questions, but unfortunately we've run out of time. Of course, I think we'll be here. So if you can catch each of us and ask questions. Thanks everyone. Thank you.